Yeah. Yep. Seems to be okay. So, without further ado, so where are we right now with the security? This is an interesting topic. I've been in the information security business for almost 20 years in one way or the other, without willingly being in this business. And initially it was, well, it was firewalls, it was antiviruses, it was very basic technologies. Nowadays it's still the same. Almost 20 years later, there's like, security business is full of different kind of firewall manufacturers, it's full of different kind of antivirus manufacturers. There's a lot of basic solutions out there. And those are being resold all the time. Full understanding what security really is, it's not really out there. It's like, it's so much more. It's about doing, it's a process. It's something that you have to do all the time. It's not that you buy a box of something that is doing certain things. You can always leverage the capabilities of technology, of course, but it's not always the full solution. So why is security broken today? Well, we keep seeing all the time different kind of information security breaches. These happen all the time. You can read about these in the news. And now when the GDPR comes out, everybody have to start telling about what has happened. So why these breaches happen? It's partially reason in the old technology that is out there. It's partially because, well, the old technology is being leveraged to build the security, but all the applications users, they have left the premises that were protected with antiviruses and firewalls and proxies and so forth. It's not really where the information is anymore. Even the applications are outside. They're in the cloud. Your data is in the cloud. Your identity is in the cloud, which is creating multiple other problems. So why this problem really exists? Mainly it's the one reason. There are multiple. I cannot, like, I have only, well, 30 minutes time to cover this, so going to every reason why this whole thing fails, it's a little bit too far-fetched. But initially, we are protecting a little bit the wrong things nowadays. So about 28% of the technical solutions, or, well, let's say 28% of the whole threat landscape is covered with the technical solutions, and everything else is pretty much left unprotected. So what is in the unprotected space, you may ask? Well, first things, how much money is being spent to the traditional technology? It is 90%, in some cases it's 100%, in some cases it's over 100% when you read the magazines. Last week in Finland there was a magazine article how many companies are actually living from the money coming from the governmental entities, and there's more money coming in than the company books actually say, so that looks a little bit weird. So there has to be overspending somewhere. So what is in the unprotected space that should be taken care of? What GDPR is all about as well. Identities, well, identity protection is left to somewhat into bad place. On the other hand, there are applications. That's where your data is. Applications are leaking like buckets. So each and every one of you here who are watching somewhere out there or sitting in the room, who have done vulnerability testing, vulnerability scanning, penetration testing, you know what's the condition of, well, web applications, for example. That's unlimited sea of work. At some stage, I have thought about giving up because I started to get into the application security and understanding how badly things really are in that world. It's kind of a place that you cannot really fix, but it doesn't mean that you shouldn't try to do it, at least. Make things a little bit harder in that. Make it better in the security-wise. So do things that get quite a lot of attention from the external parties. So 72% of attacks and malicious activities are pretty much directed into this direction. Identity is an application. Well, why is that? User identity is pretty valuable. Applications have valuable data. Users use the applications. These are things that are interesting. So every time that there is a big leak of information, it's like one of the first things that you see always in the news is that, hey, by the way, this many user identities got leaked out. This many passwords got leaked out. Why it happens? It happens because the applications, or there's something wrong with the design itself. I have spent most of today doing demos about bot detection, bot protection downstairs in the vendor hall, and it's always surprising for people how many users in their website, for example, are bots. They are something that is generated by something automatic, something that is really like, well, mindless function that will find out where is the leaky application, where is the easily stolen identity. A colleague of mine did a project in Germany a couple of weeks ago, and he was explaining that once they applied this kind of a simple anti-bot profile using a WAF in front of application, the marketing department attacked them, that they lost 80% of their visitors in their website. Well, wonder why. Those were all bots. And the main bot there was called Microsoft Internet Explorer. And there is a bot named like that. It's not the Internet Explorer users really, but it's a bot. So, can we really see and understand what is happening in the attacks today? Answer in many cases is no. More and more of the traffic is encrypted. So if you have just spent tens of thousands of euros, hundreds of thousands of euros to nice new next generation firewall, and there's a big promise that, hey, we also decrypt SSL traffic. Yeah, it might be true, it might be SSL. How about TLS? How about the new Diffie-Hellman key exchange, BFS, ECC-based keys? It's a long list of things that need to be considered there. So more and more stuff is encrypted. Nowadays, even the cyber terrorism is more or less in the world of encryption. A lot of people and a lot of companies, a lot of entities are designing their own encryption algorithms that nobody can decrypt. Then there's the standard ones that are not decrypted because we don't know are we allowed to do it, or what's the process inside EU that you can actually decrypt traffic. There are clear things that you cannot decrypt, and it's like, well, social security service traffic, banking, well, insurance companies, medical traffic, so forth. But if you never decrypt any of the traffic, now we are in a situation that 70% of internet traffic is getting to be encrypted. We are going towards a point when 100% of the traffic is encrypted. So thinking about how those legacy solutions and even the modern solutions are covering this, you need to start rethinking about the security a little bit. So it's a big thing to start kind of rethinking the security, have a different idea of security, how it should be. Basics of security are always based to 3 different things. It doesn't really change, no matter which kind of security you're talking about. It might be visibility, it might be the understanding of context. Without visibility, you cannot block, you can't detect something unless you see it. So if traffic is encrypted, you need to decrypt it to detect it, or have a really good mechanism by metadata to detect malicious activity or possibly suspicious activity there. But when you understand context, who is using what, it happens, when it happens, have full-blown understanding of the context with the security. Visibility and context understanding makes it better possibility to do smarter decisions in security. Then there's control. So if you want to control, you have to decide what do you want to protect. What is the thing that you really protect? Why do you have all those technical controls in place? Why do you have all those policy controls in place? You need to audit that. You need to check your control. Are you in control or are you not in control? Many times it said, yeah, we have all the mechanisms. We don't need anything more. Everything's perfect. Yeah, sure, fine. And then somebody gets hacked. There's always probably longest running saying is that there are 2 types of companies, those ones that have been already hacked and those that will be hacked. Pretty much, I would say already at this point that everybody have been hacked at some stage, at some point, but they probably don't even know about it because, well, visibility is not there. or understanding of control, all different vectors, it's not there. So I work for a company called F5. I have to say this, but we have been doing all those things like for a very, very long time. We started with load balancers, and then the whole thing have evolved to multiple other things, what we do. The main thing where I work and what I do for most of my days is to think about the application. So first of all, if you have an application, how do you deal with the application that way that all the application users are happy? So it comes down to understanding how the application works, how the application feels like. In a long term, it's a very long story, but I will explain it in a very short manner. You have to take care of the application, so it has to be available, it has to be optimal to use for the end user, so the end user is pretty much happy. And there has to be a plan for business continuity. Nowadays, the application is more and more business-like, so it might be that your whole business, your whole existence in the market might be just due to one application that you might have been doing or what you're using. Then there's the other thing. How do you deal with the identities? Nowadays, the identity dealing, it's pretty much a simple thing, but you have to do strong authentication. You need to know who's using your services. You should have like unified solution where you recognize all your users, all your devices in a centralized manner. No matter is the application and service running in your own data center, your partner data center, in a SaaS, in a PaaS, in a IaaS place, wherever it might be running, you should kind of deal with this. Federation is more than Microsoft ADFS. Market standard is SAML. Market standard is OAuth 2. OpenID, OpenID Connect, Java Web Tokens, all that. That's market standard. Federation is doable. Do federated access to your applications no matter where they are. So then you have single place where you can see who has logged in, used what and where, beyond your own data center. Doing VPNs nowadays, it's getting less and less. It's hard to get users to open VPN connection. You should be able to do everything using your browser. Then you are not limited to device so much anymore. Installing stuff to your devices, it's getting harder and harder if you look corporate control. When you have attackers nowadays, number one thing that is being done all the time, the question that do you really see it or do you really understand it depends where your services, applications are running. DDoS attack is number one thing nowadays if we look from the perspective of application that might break the application in some cases or might make the customers unhappy. Protecting your applications using firewall, it hasn't gone away, but you always have to think about what's the use case for the firewall. Where are your applications at? Is this a case where you need next generation firewall? So is the traffic coming from inside out, or is the traffic coming from outside in? So how do you protect your applications, really? The main thing there is that how many features do you really need to have in a firewall? If you have encrypted traffic, something that doesn't require decryption of traffic is just using reputation databases. Look at the IP header of the packet and decide, is it coming anonymous proxy, is it coming from malicious address, and so forth, and drop the traffic. The simple method is always the better. DDoS attacks, volumetric ones, anyone can go and learn from YouTube. More and more I hear from the younger people that, I never went to school to learn this one, I learned it from YouTube. Yeah, there's a YouTube video for everything. So the world is pretty interesting place. Firewalls are by no means unnecessary, but you need to think which kind of firewall you really need to have in different cases. Firewall is just one additional layer of protection to a network level, really, in the end. So when you have customers, and one of the oldest things that should be now in every place where there is application running on top of a web server, no matter is it IIS or is it Apache or is it Tomcat, there should be a web application firewall. So when you are running any page, any service that is being used by browser, there should be a WAF. There are different kind of WAFs in the world. There's these whitelisting, blacklisting ones that are passive ones, and then there are the active ones. What I've been demoing downstairs, it's been one of those active ones that is challenging the user when it comes down to a web service. So are you who you really say you are? Is the browser really suspicious? Are you a bot? Are you doing cross-site forgery, cross-site scripting? That kind of things need to be taken down. More and more it's about the bot detection, bot protection. There's more bots out there every day that are scanning and trying to figure out places where you can abuse the system. Application security is important. What WAF is doing, it understands how the application works, what are the inner thoughts of the application, and the protection is built upon that. So that should be there. Doing compliancy, I have to always put the compliancy there, but compliancy never guarantees that you are secure. Compliancy just says that you are compliant. It doesn't mean that you are 100% protected. There has been big companies that have been PCI DSS compliant, that have been hacked, and then they've been revoked of the compliancy, but still they got hacked. They got screwed in those cases. So if you have like these kind of protection already in place, what the attackers, that if they have, or they know that you have something that they really want to get from behind the application, from your data, they will attack your customers, they will attack your users. And in those cases, it comes down to a different world that needs to be protected against. And it comes down to fraud protection services. You need to understand which kind of frauds are targeted to your customers. And if you're a bank, if you're just running a web store, you cannot still install software to your client's computers. So you need to do that in a browser-based format. Do custom L7 encryption between your protected entity and your end user using JavaScript, for example. Why not? Use technologies that are being run in the client device without asking from the client. Do that. Recognize phishing sites. Tag the traffic that goes in and out. This is what we've been doing to multiple environments. Banks are paying millions for this stuff to companies like IBM, for example, that have just point solution for it. You could do it like in consolidated manner, just do everything in one place kind of approach and select what you need to do there. So how about when applications move into cloud, IaaS or SaaS? Initially, everybody thought that SaaS is pretty much equal to Office 365. It's just one SaaS application. Every company that does kind of auditing how many applications they have in SaaS, it's more than one, eventually when they go there. Some companies are already coming back from Office 365 because they had their share of issues in there, but they still go and use more and more new SaaS applications. So how to deal with SaaS applications? What normally happens is that every SaaS application will get a copy of your AD database or your user database, or there's a new silo of identities over there. If you federate that, you can deal with this issue. You can have centralized manner of logging, user identity handling, multi-factor authentication, policy handling, centralized in your own hands. If you block your user account in your AD, you have federate access. All the access to all applications in SaaS or IaaS or PaaS will be stopped in one go. If you have some kind of synchronization of your identities and their access levels per day or per hour or something else, it's not immediate. But if you do it using federation, using the assertions that are possible to do with SAML 2, for example, simple way, then you have single pane of glass of access locally and in the application when you use federate access. Cool. Then when you have the IaaS place, you can do all these things there, but you need to select what are you going to use there. Technologically, if you are using, for example, Azure, AWS, Google, they are offering you basic tools to get you up and going, but those tools are not really covering all the aspects. They are just good enough to get up and running. When you go forward, you really need to build the same things that you use in your own data center, your own environment. But then you need to select what is the right thing to do there for your architecture, your use case. When you ask the question, what are you protecting, then you know the answer for that. How about DDoS attacks? In case of F5, well, this seems to be a case with many different vendors, but in our case, we have our own DDoS protection service that is mainly SOC service. It's a combination of multiple different technologies, so it's not just F5 and we have multiple clouds and we deal with this, but it's more about understanding which kind of attacks customers are getting and protecting the customers towards multiple different things. It's more and more towards application layer rather than the network layer. There are still big volumetric attacks, and those will get bigger while the IoT is getting on its way. So when you have all these worlds in there and you want to tie those together, what we do, we use a thing called application connector, but it's basically logical encryption or encrypted connection between different cloud entities. You still need to deal with the possibilities that you have to connect to the cloud. Here in Latvia, you're pretty far from the clouds, including, well, I'm from Finland, so I'm pretty far from the clouds. We have Google in Finland, but it doesn't mean that I can get space from Google Cloud in Finland. So if I want to use clouds, I need to go to co-location, Equinix, for example, to get my own DVDM connection to cloud entities, not over the internet, but over dedicated links if I really want to leverage the cloud possibilities. Otherwise, I'm too far away by the latency. So when there are all those things that you can do, you have to always select what do you want to do. So one core thing here is the SSL inspection, SSL visibility. Do you want to look into your own users, own customers, own employees' traffic? If you want to do it, you can definitely do it, but you need to be very, very careful what you're going to decrypt. But it's possible. You can have a single point where you can have like orchestrated possibilities to look into that and allow other security devices to see that traffic. Problem with SSL, or nowadays TLS 1.1 or 1.2, is that if you have a device that can decrypt, mainly they decrypt the traffic for themselves, and then they encrypt the traffic again if they can actually decrypt the traffic in the first place. So you need to deal with that as well. So what are the two things that I want to leave behind when I leave here? One is the access control. How do you deal with the access control? There are so many different places where your users want to go. There's the cloud, there's the own data center, there's the VDI environment, there are the multiple different applications. What you really need to do, you need to have a process where you recognize possible failures in the logging. It's not one or two places where we have gone with my colleagues throughout the last couple of years that I've been at F5, where we asked that, do you have multi-factor authentication in place? Answer is no, but then there's a huge spending into security otherwise. When we ask why, the answer normally is that it's too difficult to take into use, or it's too expensive to integrate different things. No, it's not, but you need to do it in that way that you understand the architecture where you want to protect that. Even if you have the best security solution in the world in place, but then your user password and username leaks out, then your whole security system fails. Anyone can pass through. Oh yeah, I know the username and password. If you don't have any multi-factor or additional layer of security, you don't use certificates, for example, to detect your devices or users, you are screwed. So if you do successful authentication, you can show that you are who you say you are. You're coming from zero trust, you prove that you are who you say you are. If I go to a service, I log in, the system knows that, hey, it's Timo. Okay, cool. Then they can check, what should I be able to access? Okay, network, sure. Applications, why not? VDI, okay, which VDI? Citrix, VMware, Microsoft, anything is pretty much possible, but where should I go? And then cloud entities, using the federation. One place, L3, L7 control, simple implementation. You can use whichever MFA that you want, and it's easily done there. Federated access, on the other hand, it makes more possibilities. We have better use of certificates in the client end and also in the server or service end. So we have undeniable understanding what is the application and the user and the device that is using this solution. We can use assertions to make single sign-on. Once the user has logged into one application, either locally or in the SaaS, then we can use federated access using overSAML or OAuth or OpenID Connect or ADFS PIP, for example, and you get more out of that. You can have a smarter way to use applications, like network banks, internet banks, how they do. They have username and password, you can read your information, but once you start to fiddle with the money, they will ask better authentication from you. That's totally possible to do to any application, really. There are so many different applications, so many different use cases where it can be really applied. Federated access, it's more about building relationship between the users or the applications that are running in the internet, in the external databases, and the local environment. In a local data center, you probably use Kerberos, you use Radius, you use LDAP, and in the cloud, and out in there over the internet, you use SAML 2 probably, or out ADFS. Those are the ones. ADFS, by the way, is SAML 2 as well. So, but yeah, market standards, what you can use out there, make it possible to build more transparent authentication, authorization mechanisms for the end user. So information security in an application layer and access layer, it comes more transparent. Technology-wise, this is easy to implement, and it's possible to implement. So in the scale of GDPR, what is important is the user identities, the user information. And where the information ends up, it ends up to applications. If you really think about where your information is, and some of you are entering information to applications right now in the audience, and somewhere behind the screens, there are so many different ways to get the information out of the applications. A lot of those, by the way, are still working. It might be that it's just one component, one library that makes it possible, but it only takes one. Then you can get the information out. If you really want to protect the applications and data behind the applications, you really need to think about how well the application is built, what's the depth in the coding. If there are mistakes in the coding, how quickly you get patched to the application. Did it come from a major American vendor? Did it come from local small coding company? Did you do it yourself? How long will it take to fix it? It only takes one there. Traditionally, and still strong belief in the market is that actually normal firewalls can protect against these, but it's not really like that. Even IPS is blind to most of these, and especially if the traffic is encrypted, even more so. What WAF and web application firewall entities should be doing nowadays, it's more about than whitelisting. It's more about, it's beyond the whitelisting scale. It's to challenge and understand how the application really works. What are the protocols in there? JSON, AJAX, WebSockets. Something like really hot topic still is that what are you doing with the WebSockets? HTML5 WebSocket. Are you really looking into that or not? If you are not looking into that, why you are not looking into that? Is it because you don't have a technical solution for it? Or is it that you don't know about the vector, that, hey, that's a pretty nice way to leak out information? There's a lot of things that happen in the web application, but if you don't have any control for it, you should have at least a RASP in there, something that is looking from inside out what's happening on the server. But even better, WAF doesn't affect the server function so much. It's pretty much interrogating traffic that goes through the environment. So what WAF is really doing, it's checking every connection that comes in, every request. If there's anything malicious over there, it will send it back and give an error message. If there is actually request that is valid, that can be delivered to the backend service, no matter where it is. It can be in the cloud, it can be in your own data center. The WAF can be pretty much anywhere. WAF is something that is following the application. So what we like to say at F5, and what I like to say as well, is to build the security around the application. So when your application moves out from your own data center to cloud, you can move the WAF and the policy with it. Then the application follows, or the security follows the application in those cases. Even if you have a vulnerable server, we have customers, like insurance customers, that are paying for this kind of bug bounty program where there are bugs and vulnerabilities hunt down from their environment. And those findings are delivered to the vendors corresponding for the product where the vulnerability is found. A lot of the vendors are saying that, hey, you are coming from a small country of Finland, you're a small company in the scale of the whole world. This is not a bug, this is not a vulnerability, we won't patch it, we will call it a feature. So, in those cases, multiple of those are actually being protected using WAF. It might be that the patching is permanent, or it might be patching until there's the next version of that software coming out that doesn't have that vulnerability, which wasn't called vulnerability, but it was called a feature. That feature will be gone in those cases. I know that's kind of frustrating, but that happens. Bigger the company is, more likely it's to say that, hey, we won't fix it. This is the role of a WAF. WAF is there in the middle to look into what's happening. But still, nowadays the answer is that, oh, we don't need a WAF. We already have purchased an IPS, or next generation firewall that comes with an IPS. Well, they have different set of capabilities, but the role of the WAF is to sit between the user and the application and look in the traffic. If there's nothing to protect or there's no problems, it's silent. It doesn't do anything. But immediately, if there is something suspicious over there, it will start handling things. I was building one demo for the cross-site request forgery, for example, earlier this afternoon, to show after this demo downstairs. It's ridiculously easy. I was looking for an even easier way than I knew for that. And I was looking to YouTube. What is being taught in the YouTube? And I was able to do a website that is doing actually cross-site request forgery that is really working. And it's a standard way. Most of these things can be learned nowadays from internet. Internet is unlimited by that. So how about if you want to do WAF? Everybody who have tried to do WAF, they are always like, oh, it's going to take weeks or months or a year to get it running. No, it's not. It's like, then you are doing it too difficult. You shouldn't be doing like, the big problem there with WAFs, for example, is that you approach those like firewalls. Let's put every feature on and let's what it will do. Then you will definitely break the application. If you have a component in your network or environment that can break your applications, it's WAF if you use it wrong. It requires a little bit more gentle approach. Best way to do WAF is to first do policy that you can apply in front of every application and solution that you have around to get the visibility. If you know that you have vulnerable environment and you want to protect your environment, just run vulnerability scanner. Do white hat, do Qualys, do IPM scanner, do Sensic. Maybe you can do, well, I don't know, Nessus, maybe. Scan, find your vulnerabilities, deliver that to WAF, and WAF will automatically generate a policy to protect against whatever is wrong with the application. Then you start finding, do you have patches for those vulnerabilities or not? It's a couple of minutes and you have functional WAF policy. Web application firewall itself, it's an assessment tool, it's a visibility tool. I strongly recommend to test it at least. You can do it with the virtual machine. It's easy to test. In our case, for example, if you want to try F5 WAF in Azure, it takes 3 minutes to apply it from the security center over there. And you can run the trial. Easy to do. Of course, the vulnerability checking, it's also something that should be done constantly by your own people and, of course, by external parties. There was a customer case where we asked that, how often do you actually do vulnerability scanning? They told us that they just did it in 2003. Yeah, okay, just did it. It was this year when we asked it, so just 2003. Vulnerability management and vulnerability scanning, understanding what you have actually in your environment, it's pretty important. Once you have that kind of findings, you can leverage those findings with web application firewall. So, in terms of time, we started a little bit early. I hope that not so many people missed the beginning, but in a short notice, it should be a simple thing to think about how your applications are doing, where they're actually going, Are they containers? Are they in the cloud? Wherever they are, you can do pretty much all those things that I talk about. We have our own solutions, but we never say that you should be doing everything with F5, for example, but we gladly have the discussion. We are always part of the bigger solution, bigger part of the bigger picture. So, thank you.